Quick blurb on the revenue function. Revenue equals price times demand. That's a common sense statement. We've talked about it more extensively elsewhere. But revenue is how much money you get. Price is the selling price. Demand is the number sold. What you get is equal to the selling price times the number sold. If we sell for $5 a piece and we sell 300 of them, $5 times 300 sold is $1,500, and that's our revenue. That's how much we get. Now, if the price is P, the demand is X, revenue is R, this common sense notion here is expressed as R equals X times P. Take an example. Let's say that X, the demand, is 500 minus 2P. Now, what this means is if you're giving them away, there are 500 people that want them. Okay, now, every time you increase the price by $1, you reduce the number of people who want these things by 2. Now, we often accompany this by a range of possible prices. Price can't be less than 0. We're not going to pay people to buy. So the price has to be greater than or equal to 0, and the demand can't be less than 0. The demand would be 0 if 500 minus 2P was 0, and that's where P is 250. If the price is $250, then nobody's going to buy one. Okay, 2 times 250 is 500. You subtract that from 500, you get 0 demand. Now the revenue is XP, which is 500 minus 2P times P, and that equals 500P minus 2P squared. This is a quadratic function. It can easily be graphed by factor. You get R equals P times negative 2P plus 500. Zero property says that you're going to get 0 revenue if P equals 0, which is obvious. If you don't sell it, if you sell it for nothing, you're going to get nothing. And then zero property again. If you set this equal to 0, you get P equals $250, and that's the case we just saw up here. If P is 250, then X is 0. You don't get any revenue if you don't sell any of them. The task is to maximize the revenue. And to maximize the revenue, find the vertex. Of your graph of R versus P. Again, this is a quick summary of something that was discussed at some length previously.